This is a third example of chi-square goodness of fit, but in this example, we're going to look at what if we have specific proportions for each category or each group instead of saying that they're all the same. So this problem reads, or the scenario reads, in a recent study, the following percentages of U.S. retail car sales based on size were reported. 28.1% small, 47.8% mid-size, 7% large, and 17.1% luxury. A recent survey of retail car sales in Bartow County indicate that of the 100 cars sold, 25 were small, 50 were mid-size, 10 large, and 15 were luxury. At alpha equals 0.05, is there sufficient evidence to conclude that the proportions differ from those stated in the report? Again, remember, you want to look for that phrase, conclude, believe, think, and typically after that phrase is going to be your hypothesis. And in this case, the hypothesis is that the proportions differ. Differ implies not equal, which means this statement would be our alternative hypothesis. So our alternative hypothesis, again, which could be written as a sentence, we could write basically the sentence there. The proportions differ from those stated in the report. Okay. If they differ, again, remember that implies that they're not equal. The null would be the opposite, that they are equal, and we basically add the phrase do not. So we would say the proportions do not differ from those stated in the report. So you can write it as a sentence as we did before. You can also write it with the symbols, and I kind of like the symbols better because it actually shows you the percentages. We would actually say the proportion of small cars from the recent study was 28.1% or 0.281. The percentage for mid-size was 47.8 or 0.478. The percentage for large was 7% or 0.07, and the percentage for luxury was 17.1% or 0.171. And again, for the alternative, we would have to simply say at least one of those proportions differs, that it's not the same as the report that was given. Then you have the table of information. You can take the information, even though the table wasn't provided, it gives you the breakdown for the sample of the sales in Bartow County. And so you can translate that into a table so that you have different size cars and the number that were sold in Bartow County. And then you need to calculate the expected. The formula is the same. Where it's different is we sold 100 cars, and according to the survey, we should expect that 28.1% of those were small cars. And so you multiply the 100 times the percent for small cars, which was 28.1%. So basically we're looking at 28.1 cars. Mid-size, we had 100 cars sold in Bartow County, and 47 0.8% would be expected. Okay, so 0.478 or 47.8 would be expected to be small. 100 cars sold in Bartow County, 7% expected to be large. That would be 7. And then for luxury, we had 100 cars sold, 17.1%. Okay, so if you look at these numbers, first of all, realize that you can't really sell 1/10 or 8/10 of a car. So we most likely would round our expected to 28, 48, 7, and 17. Okay, and you want to ensure that that equals 100, and it does. Then you go back out to the website just like we did before, okay, and we enter the data. Okay, so I'm going out to the web page. My categories were small cars, mid-size cars, large cars, and luxury cars. Once you enter the categories, you click on Next. Just going to think about it for a minute. And then you're going to enter the observed and the expected. Now, in this case, the expected for each category will be different. Okay, as we found out. Okay, so we observed 25 small cars, but we expected 28. We sold 50 mid-size, but we expected 48. We sold 10 luxury. We expected, 10 large. We expected 7. We sold 15 luxury, and we expected 17. Our significance level, which was given to us in the problem, is 0.05. Okay, so again, you select 0.05 as your significance level. That button's already selected. And then you calculate. And it's going to think about it for a minute. And it's going to think about it for a minute. And it tells us, please select a significance level, which I did. Okay. And it tells us the chi-square value is 1.926. The p-value is 0.58796. Okay, so we can record that on our paper. Chi-square goodness of fit is 1.926. The corresponding p-value is 0.58. $58796. Okay, 58796. We compare the p-value to alpha, so 0.58796 compared to alpha, which is 0.05. P is greater than alpha, so we fail to reject the null. So if we fail to reject the null, that means that the null is true, correct, valid, whatever statements you want to use. So we would conclude the proportions do not differ from those stated in the report. So we would say, in words, at the 0.05 level of significance, there is not a preference. Use a phrasing from the actual problem, okay, that the proportions, do not differ, or you could say there is not a difference in the proportions of cars sold in Bartow County and those sold in U.S. Okay, so we're saying there's not a difference. You could say there is no preference. Proportions do not differ. Again, you can word it different ways, but again, in the end, you have basically proven that the null hypothesis could be true.